Okay, in this video I'm going to start a review for Stat 330 Exam 2. This will be part 1, so I'll go through modules 6 and 7 in this video, and I'll give some examples of types of problems you should be ready for during the exam. And then in the next video I'll do modules 8 and 9. First thing I want to say, when you are beginning your study for this exam, please go to Blackboard and download the Exam 2 review. There's a list of topics there. It's very important you go through that list of topics. Use it as a checklist that you know how to do each of those things on that list. Additionally, there's textbook problems that can help you study. And of course, you should go through all your Blackboard quizzes, your homeworks, and the handouts, supplemental handouts, or recommended handouts. Okay, so I'm going to start in Module 6. Module 6, we started talking about joint probability distribution functions. So instead of a distribution function for just x or just y, now it's a joint for x and y. So this is a discrete probability distribution function, a discrete joint probability distribution function. And so the way you'd read this is like, well, the probability that x equals 7 and y equals 9, well, you just look at the table and you say, oh, well, that's 0.08. Okay, so these are the values of x, and these are the values of y. All right, and then these are all the probabilities. So starting with what you should be able to do with joint probability distribution functions, you should be able to calculate probabilities involving x and y. Okay, so if I were to ask you at this point, like, what's a probability, say x is greater than y, right? What you should do is go through this and look, well, where does that happen? Where is x more than y? So when x is 7, is there any y value that's less than 7? No, right? What about 8? No. At 9, yeah, when x equals 9 and y equals 8, right? So that would be f of 9, 8, which is 0.25. Okay. Also, you know, what if I were to say, well, what is the probability that what is the probability x equals 7 and y equals 5, right? You just go straight to the table. That's f of 7, comma, not 5, sorry, 8. Y equals 8. Right? If it was 5, it would just be 0, because this everywhere that's not on this table is 0, right? So 7 and 8, where x is 7 and y is 8, that's 0.05. All right, so that's calculating probabilities with a discrete probability distribution function involving both x and y. You should be able to find the marginal distribution of x and y. So I'll go ahead and find the marginal distribution of, I guess, x right now, or g of x. So when you have discrete probability distribution functions, a lot of times we represent the marginals with a table. Okay, and so what are the values of x? X takes 7, 8, and 9. And the marginal distribution function, what you do is you would add this way. So 0.05 plus 0.08 plus 0.15, that is 0.28. Okay, and then again, add this way. This is 0.27. And lastly, for the last row, we have 0.45. Okay, so this is 0.28, 0.27, 0.45, right? So this is g of x right here. So you would, these guys. The reason why marginal distribution functions are called marginal distribution functions is because they're in the margins, right? They're over to the side. They're the sum of the columns and the rows, okay, for a discrete probability distribution function. All right, so this is the way you would write it as a table. You should be able to do this also for y. Now, you can always double check your answer, and you should, so I'm going to go ahead and do it right now. The sum of the values in the marginal distribution function, sum of the probabilities, should add up to 1, right? So 0.28 plus 0.27 plus 0.45 adds up to 1. Okay, good. I'm pretty sure I did my addition correctly then. Okay. All right, we should be able to calculate probabilities involving only x when we're provided with the joint probability distribution function, or when probabilities involving only y when we're provided with the joint probability distribution function. So what about the probability x equals 7? What is that? Well, that is the marginal at 7, right? So this is 0.28. Now, what about the probability that y equals 8? Okay, even though I didn't actually calculate the marginal for y, now that I have to find a probability involving only y, this will be I need to now find the marginal of y, right? So, probabilities involving both x and y, use the joint probability distribution function. When it involves only x, use the marginal of x. When it involves only y, you're going to need to use the marginal of y. So I'll go ahead and do that right now. Okay. So y takes 8, 9, and 10, and its marginals, if you were to sum downwards, so in the margin, you would have the probability of 0.33, 0.27, and 0.4. Okay, so let me double check that 0.33 plus 0.27 plus 0.4. Okay, good. That adds up to 1, so I'm good. All right, so now what's the probability y equals 8? This is h at 8, which is 0.33. All right, so now what about the probability that x is at least 8? That x is at least 8, meaning it's greater than or equal to 8. How would I find that? Well, I would basically need to think through, okay, so what values of x would that be? So that could be x equals 8, or it could be x equals 9. So I'd add those two up. Okay, so this would be 0.27 plus 0.45. Okay, so 0.27 plus 0.45 is 0.72. Alright, so you should feel comfortable calculating these type of probabilities. Alright, you should be able to calculate a conditional probability function when you provide it with the joint probability distribution function. So, a conditional probability would be something like the probability that x equals 8 given y equals 9. Okay? So to calculate this conditional probability, so remember when you had a probability involving both x and y, you needed the joint. When you had a probability only involving x, you needed the marginal for x. Well, now that we have a probability of x given y, we need to know the distribution function for x given y, right? So what is that? I'm going to write that like this. Given y equals 9. So this will be f of x comma 9, because y is given, divided by, not g, but h of 9, right? Remember conditional probability, the rule for conditional probability was the probability of, say, a given b equals the probability of a and b divided by the probability of b. Well, this is a and b, right? The joint distribution. And this is b divided by the probability of b, the marginal at y equals 9. Okay? So, this would be f of x comma 9. And then so down here, what is h of 9? Let's go look at the marginal. Let's look at it. It's 0.27. So you would plug that in. 0.27. Okay, so now if I want to find probability x equals 8, then I would plug in 8 here. And so this would be f of 8 comma 9 divided by 0.27. What's 8 comma 9? F 8, 9 is 0.07 divided by 0.27. So 0.07 divided by 0.27. All right, 0.07 divided by 0.27 is 0.259, rounding to 4 decimals, 3. All right. Also, you should be able to, what if it was the probability that x is greater than 8 given y equals 9? Now it's the same thing, except we'd have to consider all the different values that are greater than 8, right? So what are different values greater than 8? Well, actually, let me do greater than or equal to. So that would be x could be 8 or x could be 9. So you'd have to add those two up, right? So this would be f of 8 comma 9 divided by 0.27 plus x of 9 comma 9 divided by 0.27. Okay? And you can figure that out. Look at the table. Same way we figured this out. All right? Let's see. Expected values. All right, let me clean up what I got going on here. This is becoming a mess. All right, so when we're given the joint probability distribution function, we should be able to find expected values in addition to being able to find probabilities. All right? So, for example, if we were asked to find the expected value of x, y. All right, so what is expected value of x, y? Well, in general, in a discrete probability distribution function, it is the sum of x, y times f of x, y. Okay, I need a sum over both x and y. Okay. So, I could start doing this. Start with 7 times 8 times f of 7, 8. Plus, just keep on going like this. 7 times 9 times f of 7, 9. Okay? Plus 7 times 10 times f of 7, 10. Etc., etc., until you get to f of 9. Until you get to 9 times 10, f of 9, 10. Okay? So you just have to basically multiply these guys and then multiply it by the inner. Okay? So 7 times 8 times 0.05 plus 7 times 9 times 0.08, etc., until we get to 9 times 10 times 0.08. All right. So I'll leave that as an exercise for you. If you want to actually solve this and post it in the discussion board, I'll check your answer. If you want to, if you're not entirely sure how to get to the answer, more than welcome to continue talking about it there. All right. And then what if it was the expected value of x squared times y? Well, then it would be, by definition, then that would just be x squared times y times f of xy. So you just square all these x's. All right? Okay, so you should be able to find any expected value involving both x and y, given the joint probability distribution function. Now, what if the expected value is of x? Well, for given the joint probability distribution function, if it's an expected value of x, then we're going to need the marginal for x. So we're going to need the marginal for x. So if, just like in probability, if probability only involves x, then you need the marginal of x to sum across, right? But if, same thing goes, if the expected value involved only x, then you need the marginal of x to use as your sum. you use as your probability distribution function. Okay, so this would be 7 times 0.28 plus 8 times 0.27 plus 9 times 0.45. Okay. What if it was x squared, right? Then just square all of these x values. Right, you could do that too. All right. So yeah, you should be able to feel really comfortable about calculating expected values when you're provided with different PDF functions. All right. Moving on to topics in Module 7. So in Module 7, you should be able to calculate variance and standard deviation. Either if you're provided, so say I provide you with this and then ask you to find the variance of y, right? Then you should be able to find the variance of y using the marginal of y, right? If I give you just a PDF of just one random variable, then you'll use that PDF to find the variance of whatever random variable you have, right? So if I had another PDF that looked like this, right? It's not a joint PDF, but just regular PDF, a single variable, say it was 0, 1, 2, 0.5, 0.25, 0.25, right? You should be able to find the variance and expected value and all of standard deviation with this as well, okay? This would be easier because you don't need to first find the marginal, do you? Because it's already kind of marginalized because there's only one variable. All right, but if you're given the joint, you should still be able to find the variance of the one variable. So how do you do that? Well, you use the marginal distribution, right? So you need to know the equation. It's the expected value of y squared minus the expected value of y squared, right? So you'd want to start by finding the expected value. Sure, we'll find the expected value of y squared. So this would be the sum over y squared times h of y. Okay, so see, y takes the values 8 squared times 0.33, 9 squared times 0.27, 10 squared times 0.4. All right, so I'll go ahead and pull out my calculator. So that's 64 times 0.33 plus 81 times 0.27 plus 100 times 0.4. I get 82.99. Okay, now find the expected value of x, or expected value of y, sorry. Expected value of y. This time it's not squared, right? Okay, so this would be 8 times 0.33 plus 9 times 0.27 plus 10 times 0.4. Okay, so 8 times 0.33, let me plug into my calculator. 9 times 0.27, 10 times 0.4. Okay, and you get 9.07. So now you get ready to plug it into this equation over here. So this is 82.99 minus 9.07 squared. So 82.99 minus 9.07 squared, and you get 0.7251. Alright, you should always end up with a variance that's positive. If your variance is not positive, that's not good. Alright, your expected value can be negative. The expected value of y squared has to be positive though. But your expected value of y, remember there's nothing that says y, that these values 8, 9, 10, those could be negative values, right? Those are just the values of the random variable. So your expected value of y could be negative. Expected value of y squared can't be negative because you square it, so you square y, so that would get rid of any negative signs. And no matter what, your variance should always be positive. Okay, so variance is always going to be positive. All right, once you have variance, how do you find standard deviation? You should know how to do that. Okay, so standard deviation is just the square root of the variance, so just square root it. That's all you have to do. All right. You should be able to find the covariance of x and y. All right, that was another thing that we talked about in Module 7. So, covariance. You need to know the formula for covariance. It's the expected value. Oops, let me go ahead and write it down. So, covariance of x and y is the expected value of x times y minus the expected value of x times the expected value of y. Okay? Hint, since you're watching this video, good for you that you're studying. I'm going to give you a hint for the exam. Notice this relationship, the expected value of x, y equals, I can rewrite this using algebra, right? Basically subtract this from both sides. Or actually, sorry, if I add this piece here to both sides, then I can single out the expected value of x, y. Okay, you will be rewriting this and finding the expected value of x, y on the exam like this. Okay, so there's a hint for you. If you're given the covariance and you're given the expected value of x and you're given the expected value of y, you can then find the expected value of x, y. Okay. So we should know how to calculate covariance as well. So if we have to calculate covariance, then we will need to calculate all of these different little pieces. So xy times f of xy, sum it over both x and y. The condition or the expected value of x, sum over the marginal of x, and the expected value of y, sum over y times the marginal of y. Okay, so you needed to find all these pieces and then put them together like this. Okay. If you want to find the covariance for this, I'm going to leave that as an exercise for you. If you want to find it and post the answer to the discussion board, more than happy to check that. I would love to see a student do that. All right. Additionally, you should be able to find expected values and variances of linear combinations of random variable x and linear combinations of x and y. Okay, so let me talk about that for a few minutes. So, well, let me first start with the rules. Okay, so say I have ax plus by plus c, where a, b, and c are just constants, right? Then this is equal to the expected, or a, this is equal to a times the expected value of x plus b times the expected value of y plus c. Okay? So if someone tells you that the expected value of x equals 3, or not even if someone tells, maybe you found this, right? And you found the expected value of y equals 5, say, for example. Now, if someone were to say, well, let's let z equal 10x plus 3y minus 50, okay? And now they want you to find the expected value of z. Well, now you can do that because this is going to be the expected value of 10x plus 3y minus 50, right? There's no need, if you found each of these pieces, there's no need to pull out the joint distribution and you know, there's no need to do it this way. This would take you forever, right? And you could do it this way and you should get the right answer, right? This, by definition, this is what that expected value is. It's the sum over x, sum over x and y, what you're trying to find the expected value of, times the joint distribution function. That'll take you a very long time, so it's not recommended that you do that. Rather, let's use this property. So this will then be 10 times the expected value of x plus 3 times the expected value of y minus 50. So this is 10 times 3 plus 3 times 5 minus 50. 30 plus 15 minus 50. This is 45 minus 50, which is negative 5. Is it okay that the expected value is negative? Yes, of course that's okay. These random variables can be negative numbers. There's nothing saying that the random variable has to be positive. So variance must be positive, but expected values can be negative. Okay, so now moving on to if you were asked to find, say, the variance of z or some variance of some sort of linear combinations of x and y, how would you find that? So you need to know the rules for finding variance. So say a variance of a times x plus c. So first, if it doesn't involve y, so just one variable, this is a squared times the variance of x. Okay, and if you had the variance of ax plus by plus c, then this would be a squared the variance of x plus b squared times the variance of y, and the variance of c is 0, so you don't need that guy. But then you do need to consider the covariance that happens between the two. So this would be minus 2 times a b times the covariance of x and y. Okay, so if I were to tell you that the variance of x equals 2, that the variance of y equals, say, 1, and the covariance of x and y, say that equals, I'll say 0.8. Okay, now if we wanted to find the variance of z, then remember this would be the variance of 10x. Okay, what is it? 10x plus 3y minus 50. 10x plus 3y minus 50. Okay, so this would be 10 squared times the variance of x plus 3 squared times the variance of y minus 2 times a. What's a? A is 10. And b, what's b? B is 3. Now, if this was minus, so 10x minus 3y, make sure that you carry your negative with you, okay? So especially down here, if it was minus 3y, then this would be negative 3 right here, which would change that to a plus, right? Negative and negative makes a plus. Very important that you pay attention to that, okay? Here it doesn't matter as much because when you square a negative number, it's positive, so it doesn't matter. But it definitely matters here because you're not squaring it, okay? Times the covariance of xy. All right, so what do I have? I have 100 times 2 plus 9 times 1 minus 2060 times 0.8. All right, so I'll go ahead and pull up my calculator. So I have 200 plus 9 minus 60 times 0.8. Okay, and I get 161. All right, your variance of your linear combination better be positive. If it's not positive, then you have a problem. All variances are always positive. All right, so I think that concludes everything for modules 6 and 7. So, actually, I have not yet talked about joint probability distribution functions that are continuous, have I? Oh boy. Okay. That is a big deal. So I've only talked about discrete thus far. everything I talked about in terms of finding expected value, finding probabilities, you should also be able to do that for continuous probability distribution functions. So let me talk about that for a few minutes. Okay. So for example, if you have a probability distribution function, let's see, f of x, y equals, say, 2x plus y, okay, this example has dependent support, meaning x and y depend on each other in the support or in the bounds of the PDF. Okay, you should be able to do find probabilities. You should be able to do everything regardless of whether or not you have dependent or independent support. So independent support would be something like this. Something like this. For example, these guys are independent of each other. X and Y do not depend on each other in the support. Now, either way, you should be able to answer types of questions like, what's the probabilities involving X and Y, probabilities involving only X, probabilities involving only Y, expected values involving both X and Y, expected values involving only X, and expected values involving only Y. You should be able to do that regardless of if you have dependent support or independent support. Okay? Since dependent support tends to be the harder of the two, I'm going to walk through an example where I have dependent support. Now, the first thing that you should do whenever you have dependent support is draw your support. This will help you immensely as you continue. So, what I'm doing is I'm drawing where this is true. Okay. So let's see. I have x. This is the line where x equals y. You know, by the way, I think in your textbook 3.41, this was an example with dependent support, and I think it was also in your homework assignment. This is a really good example as you prepare for the exam. You should try to make sure you feel really comfortable with that type of question. Okay? So in addition to this one, this is just another example. So in this one, the line here, this line is x equals y, or you could write it as y equals x. It doesn't, these are both identical. What I'm doing here, though, is I'm writing it both. So this is the equation in terms of x, and this is the equation in terms of y. Sometimes it's not always so straightforward that you just go back and forth like that. I think in this one, it might have been like, maybe it was x plus y equals 2 or something like that. So you draw the line 2 minus x, and then this is, you have to write it both ways, so 2 minus y. So, that the line is both of these written both ways. So, anyway, sometimes you have to write it out both ways and kind of do a little bit of algebra there. Okay, so this is this line here. What do I have going on? I have whatever x is, so whatever this value is, remember this is x and this is y. So whatever x is, it's always less than whatever y is. So x is here. X can be any value less than y. Any value less than y, right? You can think about it another way where y, so say y is here, okay? Y is greater than whatever the value of x is, okay? So basically, what am I doing? It's right here, all right? That should be a dotted line because y doesn't ever equal 1, right? It just gets up to 1. All right, so this PDF takes this non-zero value in this upper triangle up here. All right, so now if someone were to ask us to find the probability, say that x is more than a half. All right. Oh, sorry. Let me make that a joint probability. X is more than a half, and y is less than 3/4. Okay, so this is a joint probability involving both x and y, so I know I'm going to be needing to integrate the joint probability distribution function. Your order of integration doesn't matter. You can do dy dx or dx dy. What does matter is that whatever your order of integration is, that it matches the bounds for your integral. Okay, so let me try to figure out where the bounds should be using this graph up here. All right, so x is more than a half. So let's say here's a half. Okay, and so x is more than a half. At the same time, y is less than 3/4. So here's 3/4, and y is less than that. Okay, so y is down here, x is, so where do these two spaces collide within this yellow triangle? They collide right here. So this is the triangle I'm going to be integrating over. Okay? All right, so let's think about this. How am I going to integrate over it? Well, if I'm going to integrate first with regards to x, where does x travel? Remember, x moves in this direction, back and forth this way, right? So starting at, actually, x doesn't move back and forth. It moves from left to right. So starting at 1/2, so starting at 1/2, I will travel until I get to whatever value of y. Okay? Then, where does y go? Y goes from down to up, right? So starting here, what is here actually? What is the value of y at that point? Remember, this line is where x equals y, right? So that is 1/2. So starting at 1/2 until I get to 3/4. All right, notice that even though I'm starting down here on this line, I don't say starting at x. Why don't I say starting at x? Well, because we've already integrated out x, right? This first piece here integrates x out. So your bounds, for your outer bounds, should never involve a random variable, right? Inner bounds may, but when you're finding a probability, the outer bounds may not. All right, so now I can just plug in my PDF. So I'll go ahead and write it down here. Have 1/2 to 3/4, 1/2 to y of 2x plus y dx dy. All right, I'll leave this as an exercise for you to integrate. At this point, I hope that most of you guys are good at double integration. If you're still struggling with it, more than happy to check your work. Love it if someone would finish this problem and post it on the discussion board. We can talk about it there. Okay. Now I want to change this problem slightly to show how important it is that you have this graph. Okay. So I'm going to change it really minorly right now. Okay. So instead of it being greater than, I'm going to change this to less than. And instead of it being less than, I'm going to change it to greater than. And let's talk about how that changes things. Okay. So, let's see. I know I'm still going to have a probability involving both x and y, so I know I will be integrating the joint probability distribution function with regards to x and y. Okay. So now x is less than 1/2. So x is moving in this direction. And y is more than 3/4. Okay, so y is up there. So where do these two things collide? On this triangle. So they collide right here in this rectangle. All right, it's a rectangle, which is really nice. We're trying to find integrals, because now I need to integrate over this rectangle, which is a lot easier than integrating over a little tiny triangle. So when I'm thinking about where's x, so starting with the bounds for x, where does x go? So let me just use a different color. X travels from 0 until we get to 1/2. 0 until we get to 1/2. See, it's not going to this line here, so it's never depending on y, right? X is going from 0 until it stops at 1/2. 0, 1/2. No matter where on this rectangle, it goes from 0 to 1/2. Okay? Then where does y travel? Y travels from 3/4 to 1. From 3/4 to 1. So from 3/4 to 1. Okay? And then you integrate the joint probability distribution function. So I'll go ahead and write that here. So 2. Okay? So you see how this changes your bounds quite a lot, right? So it goes from 0 to 1/2, 3/4 to 1, right? Before it was 1/2 to 3/4, 1/2 to y. So, I mean, you can't know where you're integrating over unless you have some sort of graph like this. You need to draw it out and understand what's going on. So like I said, you can finish these problems on your own. All right, now what if I were asked to find the marginal distribution of x or the marginal distribution of y? It doesn't matter, either one. You should be able to do that. So let's talk about that. I'll go ahead and do the marginal. Well, I'll set it up for both. So g of x. Okay, in general, g of x is you integrate over y. You integrate the joint over y. Okay, so what are our bounds for integration? Well, where does y travel from? Y goes from x to 1. Right? We can also see that on this graph. Y travels between, remember, y goes up and down. So it travels from x all the way up to 1. X to 1. X to 1, right? And I have 2 x plus y dy. Okay? Or dx, sorry. No. dy, sorry, dy. Okay? So actually, let me go ahead and do this integral so we can talk about this. So this would be, I'll pull the 2 out front. I'll have x, y plus 1/2 y squared evaluated from x to 1. So what do I have? Plugging in these values for y, I have x plus 1/2, okay, that's plugging in 1, minus x squared minus, I'm distributing the negative sign there, 1/2 x squared. Okay, so what do I have? Let's see. I'll go ahead and distribute this 2. So first off, notice that these are negative 3/2 x squared, right? When you subtract 1 from negative. Negative 1 minus 3/2 negative 1 minus 1/2 is 3/2, right? And they're common terms, x squared. So let's go and distribute the 2. You get 2x plus 1 minus 3x squared. All right, this is usually where students will stop, and if you stop here, you will lose points on the exam. You need to write your final answer. You need to define the PDF for all values of x and for all values of x, right? So it's 0 unless x is between, let's see, should I write x is between 0 and y? No, we've integrated out y at this point. So x is between 0 and 1, okay? So x is between 0 and 1. All right, and the value of the PDF is 0 otherwise. So do not forget to write your support, right? Okay, so this is the support. Don't forget to write that. All right, you should also be able to find the marginal of y. So I'll just set that up. I'll leave it for you to solve it. The marginal of y, you would integrate over x. Now, where does x, so if I'm integrating over x, integrating the joint over x, where does x travel? X travels between 0 and y. Between 0 and y. Remember, x moves from left to right. Between 0 and y. Okay? And then once you have your answer, don't forget to write that y goes between 0 and 1, and the value of the PDF is 0 otherwise. All right, you should be able to calculate, so that's how to calculate the marginal distribution, and we talked about how to calculate probabilities involving both x and y. You should be able to calculate probabilities involving only x, such as this one. To calculate this, you would first need to find the marginal distribution. If you haven't found the marginal distribution yet, this is the time where you will do it, right? If you're trying to find the probability that x is greater than 1/2. So in this case, you would integrate between 1/2 and 1, the marginal distribution. Okay? And you can do this if you want and put it on the discussion board, and I'll check your answer. So this is the marginal distribution. All right, you should be able to find expected values involving only x, right? Given a joint probability distribution function. So expected values, you would, in this case, integrate between 0 and 1 because the marginal distribution is not 0 between 0 and 1. Okay, so that's why the support is so important. Okay, if it involves only x, then you integrate only the marginal distribution. If it involves x and y, so an expected value of x and y, then you need to integrate over x and y. Okay, dx dy. So you should feel comfortable doing all of these things. You should also feel comfortable calculating a covariance and a standard deviation given a joint probability distribution function that's continuous. Okay, so say the question is find the variance of x, you should be able to do that. Find the variance of y, you should be able to do that. Find the covariance of x, y, you should be able to do that. Find the variance, find the expected value of 5x plus 1. You should be able to do that. Actually, if you had found the expected value of x, then you would just use that property that this is equal to the expected value of 5 times the expected value of x plus 1. Right? This is a linear combination of the random variable x, and so you could use that property. Okay? All right. So now this time for real, I think that covers everything that is discussed in modules 6 and 7. In the next video, I'll talk about modules 8 and 9.